Okay, this is a video on how to do regression and correlation analysis using Excel. What I've got here is the year from 1979 down to 2018. And I've got CO2 levels in the atmosphere, ppm. This is from Scripps Institute. And I got the temperature from NOAA of the Earth. Okay, so I want to know, is there a relationship between carbon dioxide and temperature? You can see here carbon dioxide is increased from about 339 up to about 410. It was actually 280 ppm when David Keeling started doing this at Mauna Loa. But let's see what we can do here. So what I'm going to do is I'm just going to highlight the CO2 and temperature columns. Come up here to insert, and I want to insert a chart. I'm going to click on that. I just want a straight scatter plot, right? This is one of the tools, 7 quality tools, basic quality tools. Click on that, and there it is, right? So this looks a little bit skewed, so I'm just going to format that axis. Looks like it's about 320 should do us. Okay, so what I've got here is on the x-axis, I got carbon dioxide ppm, and this is the temperature. And what I want to do is eventually be able to predict the temperature based on carbon dioxide. And you can see just by looking at the scatter plot, it looks like there's a positive correlation here. So what I'm going to do then next is I'm just going to click on those data points, and I'm going to come down here and I'm going to add a trend line, and this will pop up. Now I got different choices. Linear trend line is actually just a regression line, linear regression line. So that's what I want to do. I'm just going to click on that, and there it is, right? And what I can do, come down here a bit, and I can display equation on the chart, and there it is. Now the way I would use this is I would plug in whatever ppm I've got for carbon dioxide, and this would tell me the corresponding temperature. Okay, so I'm going to save that one real quick. Now what else I want to do is I'm going to click on this, and so this passed back. I want to do this r squared. I want to do this display r squared on the chart. Click on that, and that shows up. Okay, so at r squared, what that tells me is how much of the variation in temperature can be explained by carbon dioxide. So I got about 32%, if I want to explain the world's temperature, can be explained just by looking at carbon dioxide. So if I was to actually, I'm going to pull this number out, 0.3213. And what I'm going to do then is I'm just going to take the square root of that. And I got a about 56.6833% correlation, which is decent, right? Now you say, okay, so much for carbon dioxide and temperature. No. We're looking at the temperature, right? We see the variation, and we got 32% of the variation explained just by carbon dioxide. Okay, and if you look at this, right, and there are other factors in there. We go looking for what other factors in. I'm going to highlight this right here because I remember this one. This is when Pinatubo blew up in the Philippines, and it actually changed the temperature of the Earth. So if we were to know how much ash is in the Earth, we could predict that too. And we could look at other factors, how much carbon dioxide is absorbed by the ocean, how much carbon dioxide is absorbed by plants. Turns out the more carbon dioxide there is, the more plants will step up their game and absorb more. I was trying to find one where they said there's 27% more poison ivy, because the more carbon dioxide in the atmosphere, the more poison ivy it is. So what the climatologists will do is they'll start adding all these different factors and try to come up with a prediction of what the temperature is going to be. And they've gotten pretty good at it. I think they're up to about 97% of the variation in temperature. They can explain it by factors going in. So there you go. There's our regression line. There's how much the variation in temperature can be explained by carbon dioxide. And I pulled it out, the information, I gave my correlation. Okay? Kind of a long video, but I wanted you to see this.